Hey there, this video is meant to help you understand the method of elimination a lot better. And if you miss class and you need a full lesson on the method of elimination, this is meant to help you. The method of elimination means I have to solve for both x and y. I need both variable values. This is what I need. The reason is because I'm actually solving for a point of intersection between these two lines. You see, these are lines, both of them. And lines can intersect. And when they intersect, they make a point, right? And that point has an x and a y. So I just want to be clear here. I'm finding a point of intersection between these two lines. Anyway, let's proceed. So here's the thing. You remember in grade 9 when you would collect like terms? Sometimes when you collected like terms, you would eliminate a variable, right? You get rid of it. And in this case, I've got exactly that predicament, okay? So if I collect like terms across these two equations, I would actually eliminate y, because the y variable has a positive 1 and a negative 1, so they're opposites, right? Okay, so if I collect like terms, what would happen? 3x and 4x make 7x. 1y and negative 1y eliminate. And 19 and 2 make 21. I just took two equations that have two variables, and I brought it down to one equation, one variable, something that you would see in grade 8, grade 9. Divide both sides by 7. Check this out. X is going to be 21 over 7. I know that's 3. Awesome. So guess what? I found the x coordinate where my two lines that I started with intersect. Amazing. So let's take that value, because I need to find the y. Let's take this top equation. Let's call it equation 1, by the way. Let's take equation 1 and rewrite it. But let's plug in that x value that I just found. Why not? Right? I found it. Use it. 3 bracket 3 plus y equals 19. I just plugged in x. And now x is gone. Do you see that? And I just have y. Amazing. 3 times 3, that's 9. And I can go ahead and subtract 9 from both sides. That will help me isolate for y. And now y looks like y is 19 take away 9. That's 10. Amazing. So I just found my point of intersection using elimination method. So what were the steps involved to solving this problem? What did I actually do? Okay, let's break it down. So the steps involved were that I started out by choosing a variable that I wanted to eliminate. I wanted to eliminate y. Now there's a reason why I wanted to eliminate y, and that's because y already satisfied step 2. Step 2 is I want the lowest common multiple to be applied across both variable y. So in this case, I have positive 1 and negative 1. They're the same number, right? So that is the lowest common multiple between 1 and 1. It's 1. And I already had opposite signs. So I made sure that I picked a variable that was easy to eliminate. Amazing. Then I obviously collected like terms. I mentioned that, right? So I made 7x, y's went away, and I got 21, and I proceeded. I solved for x, right? So I got x equals 3, and then I plugged in that x to solve for y, and then I can potentially check my answer. This is all I did for the first example, right? So just make sure you pick a variable, lowest common multiple, collect like terms, eliminate, solve for x, plug in, solve for y. This is it. So can I use that step-by-step process in another example? Absolutely. Absolutely. Now let's do that now, right? So, okay, 4x plus 3y equals 13. Let's call that equation 1. Let's call this one equation 2. And if you notice here, y has an opposite sign, but y in this case does not have the same number, right? It's 3 and 4. So going on to step 2, what's the lowest common multiple between 3 and 4? 12. So let's go ahead and multiply the top equation by 4. And the reason why I do that is because this guy becomes a 12. This is it. And let's multiply the bottom equation by 3 so that this guy also becomes a 12. So by the end of it, I'll have plus 12 minus 12. Amazing. So let's rewrite equation 1. If I multiply 4 into every single term, 4 times 4, 16x. 4 times 3y is going to be 12y. 4 times 13, 52. Amazing. Equation 2. Let's go on to that one. 3 times 5, 15x. 3 times negative 4, negative 12y. Aha. 3 times negative 7, negative 21. Collect like terms. That's the next step, right? So, okay, 16 and 15 make 31x. 12 and negative 12 cancel or eliminate. And 52 take away 21, 31. Next step, solve for the variable. Divide by 31. X is going to be 31 over 31. That's 1 whole. Rewrite this equation down below. Okay, plug in this x value into that equation right here. So it's going to be 4 bracket 1 plus 3y equals 13. That's going to be 4 plus 3y equals 13, and go ahead and solve for the other variable. Okay. Subtract 4. 3y equals 9. Divide both sides by 3, and you get y equals 3. There is my point of intersection. It's going to be 1, 3. That's it. And now I can check my answer if I want. I'm going to check my answer at the end, though. Don't worry. And the dreaded word problem. I'm still going to use the method of elimination for this word problem, but let's see what we can do here. The store sells CDs and DVDs. CDs sell for $9 each. DVDs, however, sell for $11 each. Store sold $204 worth of CDs and DVDs. 20 items, so 20 CDs and DVDs in total, were sold. How many of each CDs and DVDs were sold? So that's what I have to find. How many CDs were sold? How many DVDs were sold? That kind of hints at what the variable should represent, right? So I'll say let C be number of CDs sold, okay? C is the number of CDs sold. So D should probably be DVDs, right? Blah, 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 okay? So C is the number of CDs sold, and D is the number of DVDs. I need to obviously make two equations, right? This is the method of elimination. Two equations. 20 items in total were sold, and C is the number of CDs, D is the number of DVDs. So if 20 items were sold, I know that C plus D in total should probably be 20. That one's the easy equation. The hard equation has to do with money. So let's think about this. CDs sell for 9 each, and C is the number sold for CDs. So if I go 9C, that probably means that's how much money the CDs alone made. If I add that to 11D, that's going to be the total amount of money that the CDs and the DVDs together sold, right? 9 per CD, C CDs, 9C is the money. So in total, I've got $204 worth. Here is my two equations. This is my linear system. Equation 1, equation 2. Again, going to all the steps. Choose a variable you want to eliminate. So I picked the second variable for the past two examples. I'm going to pick the first one, whatever. The lowest common multiple between 1 and 9 is 9. So I have to convert the top equation so that it is negative 9C. Okay, I want it to be opposite signs. That's my preference here. So I'm going to multiply the top equation, every single term, by negative 9. And so equation 1 is going to be negative 9C minus 9D equals negative 180. Equation 2 already has 9C. I'm not going to touch it. So 9C plus 11D equals 204. And now I am in the right step here. So now I can go ahead and collect like terms. Negative 9 and 9 eliminate. Negative 9 plus 11, that's going to be 2d. And negative 180 plus 204 is going to be 24. Beautiful. So let's take this equation up. 2d equals 24. Divide both sides by 2. I know that d is going to be 12. It's going to be half of 24. The number of DVDs sold to generate $204 is 12. 12 DVDs. There were a total of 20 items though, right? So if 12 of those 20 were DVDs, I know that the number of CDs is 8, right? So, okay, let's take this top equation. C plus 12 equals 20. Subtract 12 from both sides. C equals 8. There you go. So I have my answer. My answer is there were 8 CDs, there were 12 DVDs sold. By the way, I should also add, if you have a word problem, please put a therefore statement. So say, therefore, there were 8 CDs sold, 12 DVDs sold. If you guys are interested in tutoring one-on-one, feel free to contact me on the email that's showing up on screen. So I'd be happy to talk to you guys. Thank you.